Welcome to Wave Optics and Semiconductor Physics course. I'm Dr. Santosh Kumar Alla. Yeah, previously we discussed about the importance of electronic and communication engineering, and also we have seen the units, the syllabus of Wave Optics Semiconductor Physics course. So basically, the 5 units are there. Unit 1 is regarding interference. So it is related to wave optics. So previously we discussed about wave and how waves are generated and how defined wave and types of waves. And also we have seen the equation of the wave. So here a little example, through the examples how the shape of the waves decides by using the motion of the particle. So here this is also something little bit. So it's not exactly the same thing, but we can, for getting idea, this is displayed here. Now, in previous class, the wave equation y is equal to a sine omega t plus phi. So that's what we have seen. Y is equal to a, that is amplitude, sine omega t plus phi. So there I forgot to mention, or I wantedly skipped that to mention about phi. Phi is a phase. It is a simply phase. It represents phase of the wind. So this is very important concept for especially for DCE students. So you people in second year, third year, fourth year, so you are dealing with electronic circuits where you will get many things like this. Let's say resistance circuit. People used to say the current, this is current red color, and voltage, they say both are in phase. And similarly, if you see the same statement, if we have a resistance, voltage, so voltage drop where they are measured across resistors. So voltage is in phase with the current, both are in same phase. If you take inductor, there they are saying voltage leads the current by 90 degree. And here, in case of capacitor, voltage lags the current by 90 degrees. This type of terminology, these things could occur in your secondary, third year, fourth year. So for that, you have to have a basic idea on what is the phase, what is the phase difference. So let's say another example, inductance and capacitor. And also you can see, you can come across this type of questions in a series RC circuit. Voltage across the capacitor is lagging current by 90 degree, lagging source voltage by 90 degree, in phase with the current, in phase with the source voltage. Like this, you will have questions will be there. So further, you have a basic understanding of the wave is very, very important. And wave, as I said earlier, also represent like this. It is 0 degree, it is 90 degree, 180 degree, 270, 360. Now this is the for first wave. This is the first wave. Now if we take a second wave, so let's say this is the wave 2. This wave is starting from there. It is starting from this point. So that point we can say, so it is coming like this, right? It is coming like this. And of course it ends like this. This is one cycle. But here in this case, the wave is, this is the wave starting from, okay. So now what is the phase of this one? The phase of first one. Let's say it is, let's say the phase is first one, the phase is phi 1. The second one phase is phi 2. Phase is means the wave starting from where, which point it is started, how it is started. That is what is phase. So for example, wave starting from this point, that means here that is 0 degree is there. So phi 1 is equal to, it is simply 0 degree. But here this wave is not coming from 0. It is coming from where? See, let's simply by drawing a straight line. Here if you draw a straight line. So from here, if you could imagine, then wave is coming here like this. The same scenario is occurred. That means this point is what point? This is the point is here. What is the angle of this point? This angle is 90 degree. So that means phi 2 is equal to, it is simply 90 degree. See, first one wave, it is started here. So it is simply this one. And next one, it is simply started from here. See, it is actually back. It is complete wave, but it is removed. So it is started from here. It is 90 degree. So because it is 90 degree, it looks like it is starting from here. Okay, so you remove it, this part, then it look like this one. So this is what 90 degree. So the phase is 90 degree. What is the phase difference now? Phase difference is phi. So this is equal to phi is equal to phi 2 minus phi 1. Then it is 90 degree. 90 minus 0, it is simply 90 degree. And now similar way, could you tell me what is the phase of this thing? So here, this is coming, the wave is continuing like this. Complete cycle. This is the complete cycle. Now here, this is phase. This phase phi 1, it is easily we can say, it is simply, it is a 0 degree. Then what about this phase? Phi 2 is equal to what? It is coming from where? It is going down like this. So it is simply downward means it is the shape of downward is like this. The next wave is continuing like this. So it is starting from where? It is 90. It looks like 90. Sorry, 180. It is pi means 180. So now this is pi 2 is always, we'll say it is a 180 degree. Now phase difference is pi is equal to pi 2 minus pi 1 means is simply 180 degree. Now based on this, could you tell me what is the phase difference between these two? So one wave is a blue color, another wave is coming like this. So first one, if you let's say, so this is phi 1. So clearly we can say phi 1 is equal to 0 degree. Now it is our time to see what is the phase of this one, phi 2. So that we have to find. How we can find this phi 2? So phi 2 is coming like how? How it is coming? It is coming simply, and now, okay. So now it is, see, it is coming like this. Okay, it is coming like this. So what is this part of this wave? It is the part of wave, let's say, it's a normal wave. Sorry. So normal wave, how it look like in normal wave. Then now we take normally. So in general, this is how it is. So this is 90, this is 180, this is 270. Now from this uh, from this thing we can easily can see one can see the part of wave is coming from this point. Okay, so if we neglect this point, this portion if we neglect, and you extend this one, see these two are identical. So let's say so that this point is always at a 270, it look like 270. So then we can say the phase phi 2 is equal to, it is 270 degree. And always we can see the phase difference is phi is equal to phi 2 minus phi 1. It is equivalent to the, how much it is, 270. Or 270 we can write also, can write in the form of, it is 270, or you can write it is simply minus 90 degree. See here how it is minus 90. If I extend this one back side here, so from here to here, so what is this angle? This angle is 90 degree, but in negative direction, so it is 90 degree. Okay, so why 270 and 90 are identical? Because so the wave equation is what? Y is equal to a sine in brackets omega t. So now what is the phase of this one phi 2? It is a 270. So this value is same as y is equal to a sine omega t minus 90. Both are same. So that's why either we can say phase difference either 270 positive, or we can write minus 90. Both are identical. So this is about phase difference frequency. Now something, one more exercise I'm giving. So could you tell me what is the phase difference of these two waves? Okay, let's say one wave is simply, it is coming from this point, and another wave, it is simply coming from this point. Okay, so now what is the phi 1 and phi 2? So phi 2 is what? That means second wave. This is phi 2, and phi 1 is a first wave, phase phi 1. Yeah, phi 1, it clearly say it is starting from where it look like it is a 90 degree. Okay, so for example, so for your, just try to recollecting the what is a wave. So wave is, this is the wave. The first wave looking like it is starting from this point. So phi 1 is equal to, it is simply 90 degree. Phi 2 represent it is starting from this point, right? Downward. So it is what? 180 degree. So phi 2 is always 180 degree. So now, therefore, phase difference is phi is equal to phi 2 minus phi 1. That means it is 180 minus, it is simply 180 minus 90. So it is equivalent to the 90 degree. So this is the phase difference between these two waves. Yeah, like this, if you go to the previous slides, then how they are talking like a lag, and it is lag, and it is like, okay, so how they are talking here, voltage is leads by current. How they are saying, let's see here. So they are saying it is a 1, one way is like this. So now one wave current is like this, right? Current is, sorry, current is always being like this with red color represented. So this is current, right? Voltage is, let's say some other color we can take. So pink color. So voltage, according to them, voltage is like this. Okay. So current is here at starting from here. So this point is 0, but voltage is starting here what? 90 degree. What is this 90 degree? This is plus 90 degree. It is plus 90 degree. So whenever plus 90 degrees is there, then we can call it as a leading. Voltage leads by current 90 degree. Whereas in case of capacitor, the same scenario, we can check. Current, how here current is still same. It is going like this only. The phase is in the current is, so current is anyway it is 0, but if you see here, voltage is starting from where? It is starting from this point. So this point, if it is starting, that means this is what, as I said, this is 270, or we can write minus 90. How it will become minus 90? Because if we go back, this is minus 90. Whenever there is a minus 90 is there, then we can say it is a lag. Current is lagging. So this is what the language we use in the case of the electronic circuits. So therefore, so this is the phase and phase difference of the waves. Okay, thank you.